Okay, this is video 2. This again is post teaching my kids the idea of rocks, the 3 basic types of rocks. And what I'm going to do here is I'm going to draw a continental crust coming out from both, that was cute, coming out from both sides. And here in the middle, draw mid-ocean ridge with oceanic crust going, hitting, being subducted down, again on both sides. And then drawing it two-dimensionally, as well as showing convection coming from magma way down on the mantle, hot things rising, going up, hitting the crust, being forced out in both directions, causing that mid-ocean ridge. This is a convection cycle that's set up. And then we also talk about the rock, continental rock, actually having an average density of about 2.7 grams per cubic centimeter. Felsic in chemical makeup. Usually it becomes liquid, very viscous, very thick molten rock. Then we have oceanic crust, average density of about 3 grams per cubic centimeter, being mafic and being rather non-viscous when in its molten state. Okay, throw an ocean in there, somewhere around here, and we can actually throw in the things we talked about. We can throw in a continental margin, which is made out of the continental shelf, continental, whoops, let me get rid of both of those, continental slope, I'll put an S. We have a deep ocean trench. We have the abyssal plain. We can have hotter spots in the mantle, called a hot spot. This punctures holes in the mantle, actually producing volcanoes, some of which can get tall enough where they break, so we call them islands. We have other ones that used to be up towards the surface coming back down, which we call guyots. And we have seamounts, and I guess even abyssal hills. Okay, and then throw in clouds. And stormy weather. We did that for the sedimentary rock, as you recall, where water rushes down and actually puts sediments down here. These sediments can build up and get carried around down under by the subduction, where it gets melted. And when it does get melted, it actually starts moving up into this continental crust, producing blobs of molten rock. Some of these blobs actually work themselves all the way up to the surface. This gives rise to that whole partial melting section where Bowen's reaction series talks about the discontinuous side, the continuous side, where we get olivine and pyroxene and amphibole and biotite mica. And then down here we get, actually on this other side we get calcium plagioclase all the way down to sodium plagioclase. And then here we get muscovite mica, potassium feldspar, and finally quartz. So, high temperature, low temperature. So as this stuff actually goes through, and the higher materials, as it cools, the higher melting materials, the more mafic minerals actually solidify out, leaving a more and more felsic mix, and that felsic goes up, making very viscous volcanoes, very destructive volcanoes. They tend to go by the coastlines. You can see them all over the Ring of Fire. They also, same sort of thing on this side, keep the color, where this continental sediment can go down, increasing felsic type lava. We get the other thing forming like maybe right here, where we get that magma blob going up, and again that partial melting. It goes up, makes volcanoes, same sort of volcanoes, they're called stratocones or composite cones. It makes these volcanoes right off the coastline, and they get incredibly violent as well, making island arcs and basically mountain ranges. Island arcs if it's out in the water, mountain ranges if it's by the coastline. So we can actually get the mafic and the felsic to actually show up in different locations. The planet is going to probably get more and more felsic, of course, until the oceans actually, or the water washes it all away into the oceans. I think that's all I want to say about igneous rock. Throw one more thing, actually maybe a couple more. Draw a sun in the sky, draw a couple of birds, and that'll do it. Thank you much for stopping by.